Hello all, hello my dear students, welcome you all to EDIFIWAY INFINITY, and as you know, this is the lecture 5 of the chapter Motion in a Straight Line, and in this lecture we are going to learn some really important concepts, some of the derivations of many important equations that you will be using in almost all the problem of this chapter. So let's see what all are the topics we are going to discuss in this lecture. So in this lecture 5 we are going to discuss about acceleration, uniform acceleration and non-uniform acceleration. Then we will discuss instantaneous acceleration and also kinematics equation for constant acceleration. So let's see our first topic, that is what is mean by acceleration. And this may be a very familiar term for all of you, right? Why? Because while we are driving we have something called accelerator, right? And for what purpose we are using that? Yes, we are using in order to increase the speed. And if you leave the accelerator, then the speed will decrease, right? And if you need to stop the vehicle, you will apply brake. So what will be acceleration? Acceleration means it is the change in velocity per unit time. Change means always while you are discussing about change in physics, you have to consider final minus initial. Whether it is change in velocity or change in momentum or change in anything. When we are saying change in physics, you have to take final minus initial. So what will be change in velocity? Change in velocity means you will have to find the difference of final velocity as well as initial velocity. And you divide it with the time, you get the acceleration. And the another way of telling acceleration or defining acceleration is rate of change of velocity. Time rate of change of velocity. Usually in these mechanics, when we say rate of change, we are referring with respect to time. I have already told you, right? Because time is the independent quantity. All other quantity like displacement, velocity, acceleration vary based on time, right? So it is the time rate of change of velocity or simply rate of change of velocity. That's called as acceleration. So we will write the equation for acceleration as the acceleration A. A is the letter we use it to represent acceleration. Acceleration A is equal to V minus U divided by T. Where V is your final velocity, U is the initial velocity and T is the time. So you have to note V is your final velocity. V is your final velocity and U is your initial velocity. U is the initial velocity and T is nothing but the time taken to change the velocity from U to V. That is called time. T is called time. And now you have to understand that when your final velocity is greater than the initial velocity, that is the case where a vehicle is going slow, then it increases the speed, right? Increases the velocity. That case, then you can say the acceleration is positive. The acceleration is positive. And now when your final velocity is less than the initial velocity, then you can say your acceleration is negative. Clear? So it is the case where a body is initially moving with a high velocity, then the velocity is decreasing. Then the acceleration is negative. Such negative acceleration is called as deceleration or even retardation. So when in the question it is given deceleration or retardation, you have to understand it is negative acceleration, the final velocity is less. Clear? Now what is the unit for acceleration? What is the SI unit? What about the SI unit? What about the SI unit? For velocity it is meter per second, and for time again it is second. So it is meter per second square. Okay, that is the unit for acceleration. Clear? And this is a very simple concept, right? Now let's see what is meant by uniform acceleration as well as non-uniform acceleration. Okay. So uniform acceleration means the body have constant acceleration. Okay. Do you remember we have learned about uniform motion and non-uniform motion, right? The word uniform means constant. The word non-uniform means varying, right? So uniform acceleration means the body is moving with a constant acceleration. There is change in velocity. Due to the change in velocity, the body have acceleration, and the acceleration value of the body should remain constant. If it was initially traveling with 5 meter per second square acceleration, then that 5 meter per second square should remain as such after any time. Clear? And non-uniform acceleration means the body is having a varying acceleration. If it was initially 5 meter per second square, then after sometimes it may become 7 meter per second square, then it may become 12 meter per second square. Okay, which means that the acceleration is also varying with respect to time. Clear? Such case is called as non-uniform acceleration. Okay, and the other important point, when we refer to uniform acceleration, the change in the velocity, that is v minus u, right? That is change in velocity. That change in velocity will be equal in equal interval of time. What does it mean? Yes, in order to understand that point, you have to consider an example. Okay, I'll give you an example. Let's consider a body that is moving. Okay, so initially the time will be 0 seconds, then it will become 2 seconds, okay, 4 seconds, 6 seconds. We will consider equal interval of time. And suppose initially the body was at rest, which means it is 0 meter per second will be the velocity. Clear? Then after some times it become 4 meter per second, then it becomes 8 meter per second, then it becomes 12 meter per second. So this is the example of a body where the change in velocity is equal in equal interval of time. Let us find out the acceleration from this. Okay, so we know, we'll change the pen color. Okay, yes, acceleration means change in velocity per unit time. So let's find the acceleration for this interval 0 to 2 seconds. So what is the change in velocity? Change in velocity is v minus u, right? In this case it is 4 minus 0, which is 4, right? So here acceleration is, change in velocity is 4, the time taken is 2 seconds, so 4 by 2 will be 2 meter per second square. Clear? Now let's find the acceleration from 2 second to 4 second. Okay, 2 second to 4 second, what it will be? Yes, here also the acceleration will be, the final velocity is 8 meter per second, the initial velocity is 4 meter per second. So 8 minus 4, okay, 8 minus 4, 8 minus 4 is 4, right? And the time taken is 2 seconds, so again it becomes 2 meter per second square. Similarly, if you calculate for 4 second to 6 second, the acceleration will be same, that is 2 meter per second square. Clear? Just meter per second square unit. Okay, so which means that if the change in velocity is equal in equal interval of time, then the acceleration value will remain a constant. Everywhere you get the same acceleration, 2 meter per second square. Right? Now, if the body is having a non-uniform acceleration, okay, the body is having a non-uniform acceleration, that means the change in velocity is not equal or even unequal. Okay, not equal or unequal in equal interval of time. Okay. So let's see an example for that. If the body is having unequal change in interval, let's see an example for that. If the body is having unequal change in velocity, whether the acceleration will be non-uniform or uniform. Let's see that. Okay, we'll take an example and we will see that. So you have to note these examples also. Okay, if they are asking in the examination, then you have to give this example. Clear? So I'll erase this. So now let's consider the motion of another body. 0 seconds, 2 seconds, 4 seconds, 6 seconds. Okay, that is equal interval of time. Now let the velocity be at 0 second, let it be 0 meter per second. At 2 seconds, suppose it is 2 meter per second. At 4 seconds, it becomes 5 meter per second. At 6 seconds, it becomes 9 meter per second. So here you can clearly see the change in the velocity is unequal, right? Here the change in velocity is 2 minus 0, that is 2 meter per second. Here the change in velocity is finally is 5 meter per second, initially is 2 meter per second. So 5 minus 2, that is 3 meter per second. And here the change in velocity is 9 minus 5, right? That is 4 meter per second. So the change in velocity is unequal. Now let us find out the acceleration from 0 to 2 seconds. The acceleration could be change in velocity divided by time. The change in velocity is 2 meter per second by the time is 2 seconds. So the acceleration value is 1 meter per second square. Clear? Now from 2 seconds to 4 seconds, the change in velocity is 5 meter per second divided by, what about the time interval? It is 2 seconds. So 5 by 2, you are going to get 2.5 meter per second square. Alright? Now from 4 seconds to 6 seconds, your acceleration is going to be, change in velocity is 4, and what about the time? The time is 2, so 4 by 2, you will get the answer as 2 meter per second square. So you can clearly see that since the body is having unequal change in velocity in equal interval of time, the acceleration values are different. Initially it was 1 meter per second square, then you get it as 2.5 meter per second square, then you get that as 2 meter per second square. So the acceleration is changing as the time is passing, right? So this is called as non-uniform acceleration. I hope you get the concept. Okay, now let's see what is meant by instantaneous acceleration. Do you remember what was instantaneous velocity? Yes, it is the velocity at the instant we are looking, right? At the instant we are measuring, right? So what will be instantaneous acceleration? It is the acceleration at a particular instant of time. Clear? Let's consider a case. Let's consider a case where the change in velocity is very small, that is dv, and let the time taken to change this velocity be dt. Clear? Then what could be acceleration? Then what could be acceleration? We know acceleration is change in the velocity, that is v minus u, which can be represented as delta v, by the change in time or the time taken. Okay, so here the delta v is nothing but it is dv by the time taken is dt, right? Sorry, time taken is dt, right? So dv by dt is the equation for instantaneous acceleration. Clear? Very important. Okay, now as I have already mentioned, it is from calculus. You have to apply some limit concept here, but we are not going to all such things because right now you are not familiar with calculus. Okay, calculus is basically the branch of mathematics where we deal with differentiation, integration, many mathematic process. Okay, and you are not familiar with that. So it is a simplified way to learn this concept. Okay, now let's come back here. Come back to uniform acceleration as well as non-uniform acceleration. Okay, for uniform acceleration, you can always use the equation A is equal to v minus u by t or delta v by t, where delta v is the change in velocity. Clear? Now for non-uniform acceleration, you have to use calculus method. Okay, we have only calculus method. Okay, sometimes while I am writing there could be some spelling mistake. Okay, so what you have to do? You have to check it and you have to write it properly. Okay, since I am only focusing on the concept part, there can be some sort of spelling mistakes. Okay, so don't mind that. Okay, now we have only calculus method for non-uniform acceleration. Okay, so there we can say the acceleration is dv by dt. We can only apply differentiation. Clear? So you have to remember this. Okay, now for uniform acceleration you have kinematics equation. Okay, kinematics equation. Kinematics equation, there are basically three equations, and that three equations you have learned in your previous classes also. It is familiar to you. Here we will be learning their derivations too. Okay, so kinematics equation are used for the case where the body have a constant acceleration or a uniform acceleration. Okay, if the body have a non-uniform acceleration, then you have to apply calculus method. So I will be teaching you what is calculus method later. Clear? So in this lecture, next we are going to learn kinematics equation for constant acceleration. Basically there are three equations. We are going to derive that three equations. Okay, so here I am using graphical method. There are some other methods available, but it is better to learn graphical method. Clear? So let's consider a case where initially a body is moving with a velocity u. Clear? So I am drawing a graph for that. Okay, there is a graph. On the x-axis we will mark time, and on the y-axis we will mark velocity. Okay, now this is the origin. Suppose initially the body is moving with a velocity u. Clear? Now within a time t, the body makes some acceleration and reach at a velocity v. Okay, the body velocity increases to a value, okay, to a value v within time t. Clear? So this is the case. We are having a body that was moving with a velocity u initially, then within time t the velocity becomes v. That's the final velocity. Time taken is t. Clear? So here we have to derive the velocity time relation. Here is an important point, that is acceleration is the slope of velocity time graph. Okay, so you have to remember that acceleration is the slope of velocity time graph, that is vt graph. Okay, vt graph. So you have to find acceleration from this graph. So the slope means it is delta y by delta x. Okay, change in y by change in x. Right now you just understand like that. Later we will be discussing all those mathematical concepts. What is slope, what is acceleration, what is differentiation, what is integration, everything. Okay, that time it will become very clear for you. For this time, just you remember your slope means it is delta y by delta x. So we can say that your acceleration is delta y by delta x, because acceleration is the slope of vt graph. We have just discussed now, right? Okay. Now from here, what is delta y? Delta y means, I'll just erase it. Okay, delta y is, this is your delta y, alright? That will be v minus u. Am I right? V minus u. Okay, we'll get this as v minus u. Okay, and what about delta x? Delta x is the time, right? So that time is basically t. Okay, that time is basically t. So here it becomes v minus u by t. Okay, now let's rearranging that. It becomes at is equal to v minus u. Okay, now let's take this minus u to the left hand side, so that your final velocity v is equal to u plus at. This is a very important equation Okay, and this relation is called as velocity time relation. Clear to you? And you have to copy all those things. Okay, so copy this. Clear? Now we will learn what is the next derivation, and let me tell you something. This graph you have to draw for every derivation, whether they ask you velocity time relation, whether they ask you position time relation or position velocity relation. Okay, total we have 3 derivation. So in all these derivation the graph remains the same. Okay, so I will not be drawing the graph again and again. Okay, so let's see what is position time relation. Position means you are referring to displacement. Okay, so how to find the displacement? That is the next point you have to remember. That is basically displacement, that is S. Okay, displacement, area under velocity time graph. Okay, it is the area under VT graph. Okay, we will write it as VT graph. Okay, VT graph. You have to take down all these points. Okay, it is very important. Okay, now what about the displacement? What about the area? How to find the area? This is your graph, right? So let's mark some points here. Let this point be A, let it be B, let it be C, then D, E. Okay, A, B, C, D, E. Now the area means, how to find the area under this graph? How to find the area? The area can be found as the area of this triangle plus area of this rectangle. Am I right? The area under this curve BC can be found as area of triangle plus area of rectangle. Clear? Okay. So let it be area of triangle plus area of rectangle. Okay. Now what is the area of triangle? The area of triangle is half into base into height plus, what about the area of rectangle? It is length into breadth, right? Length into breadth. Okay. So it is half into, what about the base? What about the base? The base of this triangle is BD, which is equal to T, right? Which is equal to T. So T into, and what about the height? This is basically the height, right? V minus U. Okay, height is basically V minus U, right? Height is V minus U. So it is V minus U plus length into breadth of the rectangle. How to find that? Length into breadth of the rectangle. Here the length, this is the length, right? And this is the breadth. Okay, so length is basically T and the breadth is basically U. Okay, length is T and breadth is U. Okay. So this is UT. Clear? Now let it be question number 1. Okay, let it be question number 1. We have learned our V is equal to U plus AT, right? From there you can say your V minus U is going to be AT. That, let it be question number 2. So put 2n1. Okay, so you get that S is equal to half T. Instead of this V minus U, you put AT. Okay, so into AT plus, then there is UT remaining. So it becomes S is equal to UT plus half AT square, right? T into T is T square. Clear? So this is the position time relation. Okay, very important. Position time relation. Okay, so you copy down all these things to your notebook. Okay, now let's learn what is the third relation. That relation is called as position velocity relation. Okay, now position velocity relation also you are finding basically the position. So position is the area under velocity time graph. You remember that point, right? Now looking at this geometrical figure, there is A, B, C, D, E. Do you think it is a trapezium? Yes, it is a trapezium, right? What is trapezium? In a trapezium there will be two parallel sides, right? So in this figure the AB is parallel to EC, right? Which means there are two parallel sides. This could be a trapezium. And how to find the area of trapezium? Do you know that? Okay, I'll tell you. Area of trapezium. Okay. Suppose this is a trapezium. Okay. This is a trapezium. A, B, C, D. So here CD is parallel to AB. Okay. So let AB be taken as B. Okay. That side is of length B. And the CD have a length say A, and let the height of this trapezium be H, then the area could be H by 2 into A plus B. You have to remember this, very important. Okay, so how to apply this equation to find the displacement here? The displacement can be written as H by 2 into A plus B. And what about the height of that trapezium? Let's find it out. So here you can see the height. This is the height, right? This is the height. This is A and this could be B. Clear? So your height is T. Okay. So that is T by 2 into A plus B. So what was A? A was U and B is V. Okay, so U plus V. So A plus B is U plus V, right? U plus V. Okay. Now take this 2 to the left hand side, we get 2S is equal to U plus V into T, right? And let it be equation number 1. Okay. Now we know V is equal to U plus AT, right? From there we can write V minus U is equal to AT, and there your T is equal to V minus U divided by A. That is equation number 2. Clear? Now let's substitute the second equation in this first one. Okay, so put 2N1. So you get 2S is equal to V plus U into. What about time? The time is V minus U divided by A. Okay, so let's take this A to the left hand side. So we get 2AS is equal to V plus U into V minus U. Alright? Do you remember the identity? A plus B into A minus B is equal to A square minus B square. Okay, so let's apply that here. We write 2AS is equal to A square is V square and B square will be U square. Clear? So this equation is called as position velocity relation. Okay, so we have learned 3 relations: velocity time relation, position time relation and position velocity relation. These 3 equations are collectively called as kinematics equation for constant acceleration. Okay, so this is very important in order to do problem. So we will be working out many numerical questions in order to learn the way we have to use these equations. Okay, so see you all in the next lecture. and stay tuned with EDIFIWAY Infinity. Bye bye.